Hello friends, as last time we have seen the cycloid curve. Here we must know that the cycloid comes in two types as well. One is called epicycloid, second one is hypocycloid. Now what are these epicycloid and hypocycloid? So epicycloid is also type of cycloid curve, that is we are going to trace any point present on the circumference of a circle, but provided that the circle is rolling on the outer surface of another circle, that is called epicycloid. So here, as per the given problem, the radius of directing circle is given 75 mm and the diameter of rolling circle is given 50 mm. So very first upon we will draw the radius of directing circle, which is 75 mm. Now once you draw this 75 mm distance, so by taking end point of this line as center point, we can draw an arc of radius 75 mm here. Now this is a part of what? Outer circle on which the rolling circle is going to be rolled. Now we are going to extend that line further beyond directing circle of length 50 mm. By taking this length is 50 mm, we can mark the midpoint of this line at a distance of 25 mm. So we get the center point, and by taking this center point, draw a circle of radius 25 mm. Now to roll this circle in forward direction, this circle must roll in clockwise sense, right? So this circle is called the rolling circle of radius small r. In our problem, it is now 25. Now like cycloid, we are going to divide this circle also into 8 number of equal parts. So we'll draw the very first one, we'll draw the perpendicular line to the first line, and then we'll draw by angle bisector. So we get 8 equal parts. Now we need to trace a point P which is in contact with this directing circle. But to trace this point, we must have this rolling circle must have completed one complete revolution. On straight line path, it was very easy to mark a pi d distance where the circle will be completing one complete revolution. You have to measure an angle theta where the final position will come. There is one formula to calculate this theta. So theta is given by small r upon capital R multiplied by 360 degree. Using this formula, you can compute the angle between this initial position and final positions. Once we have initial position and final position, which is comprised by angle theta, we can divide this theta also into 8 number of equal parts. So whatever this theta, just measure the theta and you can divide the theta into 8 number of equal parts. You can also use angle bisector method to divide the total angle into 8 equal parts. Once it is done, now it's time to draw the construction lines from each and every respective point which is present on the circumference of a circle. Now in this case, from this point O, this is the origin point O. From this point O, we'll take O to C as radius and O as the center. We'll draw an arc from point C. So we get, this is what, a center line arc which has been divided into 8 number of equal parts. So after getting center line path, you can draw paths from different respective point, like you can take point O as center and O to 3 as the radius. So O to 3 as the radius, you can draw an arc here. So like that you get this one, O to 2 as the radius and O as center, draw another arc, you will get this path. Then O to 1 as the radius, this is O, O to 1 as the radius and O as the center point, draw another arc. So these are what the arcs you have drawn. You can see 1 and 7 are coming on the same arc, 2 and 6 are coming on a same arc, and then 3 and 5 are also coming on the same arc. You already have center line paths and you have divided the theta into 8 number of equal parts. So you can mark on the respective points as C1, C2, C3 up to C8. So very first thing, when circle will be moving in one division ahead, like C to C1, P will be moving from 8 to 1. So by keeping point C1 as center and CP as radius, cut an arc on a path which starts from 1. So friends, let's see step by step how we can draw this epicycloid curve. Very first thing, we'll take CP distance in compass, and this distance we are going to mark from point C1 as a center on a arc which starts from point 1, and here we get first point. Later on we will be keeping the same distance in compass, and that distance again we are going to cut an arc, but this time we are going to take C2 point as a center and on an arc which starts from point 2. So this is part 2. Here we are going to mark the point and we get the second point, second intermediate point. Like that, again by keeping the same distance only, we are going to cut an arc from point C3 as a center on a path or on an arc which starts from point 3. We get third point. Continue this like from C4 to 4, C5 to 5, C6 to 6, like that, C8 to 8. Like that you will get total 8 number of points, and later on you are supposed to join all these points by smooth curve. So this curve is called epicycloid curve. So guys, that's all about epicycloid curve when a circle is rolling over the circumference of another circle. So I hope this video help you in understanding epicycloid. Thank you.